Let's maximize the function z equals 6x plus 3y. It's subject to the constraints 8x minus y less than or equal to 16, 2x plus y greater than or equal to 10, x greater than or equal to 1, and y less than or equal to 9. And as you can see, we have a graph of this area with the shaded area, and you're asked to find the maximum value and where we want to find the maximum value and where it's located. So let's look at what we have here. So we're going to need to know the corner points, which we have those. We have 4 of them, and 2 of them are pretty readily available for us. We can actually just write those down. It looks like we have 1, 8, 1, 8, and we have 1, 9. Now the other 2 are a little hard to tell from the graph, and you can guess, but you're not going to get the correct maximum value. You can get close to it, but it would be really hard to get that value. So how can I figure out what these points are? Well, that's where we solve a system of equations. We want to find out where they intersect. So we're going to look at, we'll start with the first one. We'll start with these 2 lines right here where they intersect. And so let's see, that is this equation, and that is y equals 9. And then the other line is the green line that intersects it, and that is 8x minus y equals 16. And this is what we're going to solve. We're going to do this just as a system of equations in previous section and solve this, and it's already set up to do by elimination, because when I add these 2 together, I get 8x equals, I'm sorry, that's a 9, not a 1. That should be 9. I think I said 9, but wrote 1. So that should be 25. And then divide both sides by 8. And x equals 25 over 8. So there's my x value. And the y value, we already know what it is. It's 9. So there is another corner point, 25 over 8, 9. And now we need to find where the green line and the blue line intersect. Well, we already knew the green line is 8x minus y equals 16. And the blue line is the 2x plus y equals 10. And again, this is a very nice system of equations because when I add them together, my y's cancel each other out. But I have 10x equals 26. And then x equals 26 divided by 10, and I can reduce that to 13 over 5. So I have 13 over 5. And I need to find my y value, so I will need to take this 13 over 5 and plug it back into one of the 2 equations. So let me get us a clean sheet here. So I'm going to use the 2x plus y and plug in my x value to find out what my y value is. So that's going to be 26 over 5 plus y equals 10. And then y is going to equal 10 minus 26 over 5. And if I get a common denominator, that's going to be 50 over 5 minus 26 over 5, which equals 24 over 5. So there is my y value, 24 over 5. Now there are all of my corner points, and we need to check those to see which one is the maximum, or which one of these gives us the maximum value. So let's look at all of those corner points with our objective function. Now remember what our objective function was. It was z equals 6x plus 3y. And we're going to plug in our corner points. We have 1, 8, 1, 9, 25 over 8, 9, and 13, 5, 24, 5. And we'll plug each one of these into our function. All right, that's a plus there. times 8 equals, and 6, that's going to be 30. 24 plus 6 is 30. And then 6 times 1 plus 3 times 9. And that's 27 plus 6, which is 33. 6 times 25 over 8 plus 3 times 9. And this gives me 183 over 4 when you get a common denominator. And simplify. And then last but not least is 6 times 13 over 5 plus 3 times 24 over 5 equals 30. And you can also use your calculator. Just remember the question is asking for it to be typed as an integer or simplified fraction. So it's going to want a fraction answer. And so the larger of all of these is the 183 over 4. Because if you actually divide that, 183 divided by 4 is approximately 45.75. So that's higher than any of my other numbers. Okay, so that's going to be the maximum value. Okay, so the maximum value is 183 over 4. And then where does it occur? Well, it occurs at the point. 25 over 8, 9. So that's where your maximum value occurs.